Good morning, everybody, or good evening, wherever you are. And thanks so much for joining us for this XML-athon. We're going to have a lot of fun. My name's Don Murray, and I'm on here with Dean. Hey, Dean.
Yeah, good morning, everybody. Thanks for taking the time to join us. And yeah, we're definitely have a lot of fun things to go through here. So
Yeah,
hopefully you've got a coffee or two and are ready to roll.
that's right. And we also have Trent online who, hey, Trent.
Morning, everyone.
Yeah, and Trent also is an XML enthusiast, and we have a team of safers in the back there that, like me, have had trouble sleeping last night. They're so excited. So we'll get started. I'm just gonna turn off my my webcam here, and we'll get going. So so we introduced ourselves. Dean is really the the senior FME data expert on XML. So anything XML, Dean is the guy. Works very closely with Trent, of course, and I love XML, but I got to say that Dean probably more lives XML because he works with it every day. And any of you who have worked with XML or GML or JSON formats have probably come in contact with Dean and or Trent. Yeah.
And we should mention Juan. We should mention
right.
Juan.
Yeah, Juan is the guy in the back who basically built all this amazing technology, and Dean and I, of course, work very, very closely with Juan and his team to make XML easy and fun. So yeah. So here's the agenda. What we're going to go through. We're basically just going to talk about SAFE and the platform and some of the highlights, the things that we do to make XML easy to work with. And then we have, this is called an XML-athon. So we have a nice, cool dozen demos that we can go through. So yeah, so lots going on. First, for some of you who are new, what is SAFE's mission? Our mission at SAFE is very simple. We help organizations maximize the value of data, and that's it. And there's lots of data in many formats, and XML is one of them that we work with. And we have a no-code platform, so you can build things graphically. So if you're working with XML, for example, you don't have to be a programmer who knows XSLT, or we also have our own technology called XF Maps. You can just do it all graphically. We have an authoring environment where you build the low-level transformations and moving XML in and out of systems. And then we have a server where you can automate those workflows to be triggered based on maybe emails arriving with XML, or maybe there's an application who uses XML to push data out. And then we have FME Cloud, which is FME server in the cloud, and there's several offerings there. We also have mobile apps that are a nice front end to enable you to leverage FME server as well. So FME is a data integration platform, and the big thing is that it's the only one that really embraces spatial. A special call out here to the Esri data interoperability extension. You can think of it as another authoring environment. It is FME desktop, branded under the Esri brand, and we're working very, very closely with them to make sure that we support all the things that Esri is up to. Trent, for example, has worked very closely with them on the utility network, and there's some pretty exciting things coming in the data interoperability extension in 2.6, and you can learn about that next week at the Esri show. But if you're a user of ArcGIS data interoperability extension, or you're a big user of Esri, you'll want to tune in and find out about that. Okay, so yeah, so let's get started and have some fun. And you can see nice little logo there, our FME logo. You can just see how much we embrace XML. Even our logo is transformed into.
Yep. So Don, I'm going to throw something out there. Why XML? And when I say that, I don't mean that's a new format I'm throwing at you. But why do you love XML so much, and why should we care about it?
Dean, I think you might have seen my slide deck. Okay, so yeah, so why is so first I'll say FME support for XML is wide and deep. why do I love XML? Well, XML is a single format or encoding that enables us to work with so many different types of data. So it doesn't matter whether it's GIS or CAD. It doesn't matter whether it's point clouds even you can put in XML. And I just think XML is beautiful. It's human readable. You can open it up in a standard XML tool or a browser. You can look at it and start to understand the data very easily. And there's lots of beautiful XML out there. The challenge with XML is sometimes it's so powerful that people embrace and they want to use all the different facilities in XML. And in those cases, you really do need a tool like FME. We've been working on XML for 22 years. And our goal has always been make it easy so anybody who gets an XML data set can simply just work with it without writing code or having to understand XSLT or any of those low-level systems. So, yeah.
Yeah, Don, we were chatting about that just before we started, and it sounds like we've supported XML. Our support for XML predates Workbench, so that kind of gives you an idea for how long we've had that.
Yeah, started, and Dale mentioned it started with our partners in Dotted Eyes in the UK. When I met them in Marco Island, there was an OS, the Ordnance Survey. They had were moving from their proprietary to the XML format. It's a vendor neutral format, and you can just see all the different ones that FME supports out of the box. You'll also see there is this generic XML, so we can read anything. And we're going to go through. So yeah, so all the formats are XML there. And what we've done is if we look at CityGML, for example, it is, so you could read CityGML with XML, and then you would just get all the raw XML pieces. You could also read it with GML, and then you get the geometry, and then you could read it with CityGML. So when you're working with an XML format, the first thing you want to do is look and understand what your data set is, and then look at FME and find the most specific format. So yeah, and CityGML is a good example, and I think Dean's going to show us something. But the model is look for the most specific reader, saves put effort into giving you a great presentation, pulling all the pieces together so that it's really easy to work with. Yeah, and so you want to go through? You're going to go through that, Dean?
Yeah.
Okay, so yeah, so this is. Yeah, so this is just Dean. So when you get these slides, you'll be able to see what Dean has done, and yeah. So what about Json? We love Json too. Json we often refer to as XML's baby brother, and yeah, and so everything you see here about Json, often the patterns also work with XML. Yeah, so we love Json too. Yeah, and there's some of the Json formats. Json often works right out of the box really simply, but you can see there are some specific Json formats there that deserve a call out. IMDF, which is the indoor mapping data format, that was created by Apple and has now become an OGC standard. CityJSON, of course, which is again like CityGML. It's a newer format that has uses a JSON encoding rather than the XML encoding, and TopoJSON. So we're seeing a lot of activity in the JSON front, and those two are done by the same team that does XML because there is a lot of the similar challenges, similar encodings and things like that. JSON doesn't have inheritance, it doesn't have substitution groups, and sometimes those are the things that can get people into trouble when they're trying to read or write.
Yeah, and we're seeing a bit of a push on like at the OGC, for example, and even within the Inspire community towards alternate encodings, so lighter weight encodings, and that's why you've got CityJSON, and there's likely to be JSON variants. Well, there's the whole Open API, which I'll mention a little bit later, where doing the OGC services, but via REST and JSON and GeoJSON rather than the just GML.
Yeah. And when it comes to web services, many web services do support XML or JSON, but by far and large, Json is the language of web services. And so we spend a lot of time on improving that support too. So, and then you can see some, you can just see the breadth of the industry support for some of these formats. So yeah, so some of the things we've at SAFE, what FME has embraced. New now is in 2020, I believe. Was it 2020 or 2019 where XSD really started to be a big thing as far as, remember, Dean?
Yeah, it's just I think 2020 was really when we launched that XSD-based XML reading and writing. We've had XSD-based GML reading and writing now for a number of years, but it's only in the last year for XML.
Yeah. So, and you can see, so we have standard XML for if you just get an arbitrary XML, you look in the format of SAFE, it's not there. And there's just thousands and thousands of arbitrary XML that's being that people are using to share data. GML, of course, is geographic markup language, and that's the OGC standard embraced by large projects like Inspire and things like that. So we've had that for a long time. And then WFS, Web Feature Services, again, we are a great client for consuming that. And
and really one of the few clients that can actually handle the full rich GML support. So there's a lot of WFS clients that can really are limited to basic or simple features, but we can handle nested complex properties as well.
Yeah. So one of the things we promised we would answer is, does the Zipster run on XML or love XML? So what do you think, Dean?
That's a tough one. I think you just added a slide. I think the Zipster is, maybe he's actually made out of XML. We'll see.
Right. Okay. So let's see. So no, he loves XML. So there you go. So the Zipster loves XML, but if you dig a little deeper, you find out that the Zipster runs on machine code that just happens to be called extraordinary machine language. So there you go. So
it's both.
Yeah, it's close. Yeah, it is an XML, but a different XML. So yeah, so there you go. So of course, with FME being a no-code environment, we build these transformers that are specific to things. So if you look for raster, for example, you're going to find a lot of raster transformers. And then similarly with XML, we have a lot of transformers we've built so that you can start to understand, pull apart, rearrange, extract pieces of the XML you want, validate all these things without having to write code. And that's really the key there. So we're going to highlight a few of these as Dean goes through his demos, and some favorites there.
What's your favorite, Don?
I use the XML Flattener a lot. Like whenever I get a new data set, I use the XML Flattener, and then because often I can do what I need to do with that. The XML Updater I've used from time to time too, to basically be able to take an XML document and insert something into it or pull something out or delete and all those sorts of things. How about you?
I'd have to go with XML Xquery Exploder. I think it would just look good on a t-shirt. But just for the name.
Yeah.
But I think in practice, Templater's gotta take the cake. You can write anything with Templater, right?
It's got great historical. Yeah. So when we released, that was really the first time it's got to go back 10 years. And when that first came out, then we had the ability in FME for the first time to build really complex nested XML. And I remember saying to Dean, "Come on, Dean, you should be able to write anything in using the XML Templater." And I was just like, I get excited about stuff, as I'm sure you can tell. And I was like, "Oh yeah, the XML Templater, that's just the most fantastic thing ever." And it's still useful, of course. But if you have XSDs now, you can do such a better job writing with less effort using the XSD. So yeah. So Dean, thank you for surviving and putting up with me through my, euphoria over XML.
I learned a lot in the process, so I survived. Yeah. What doesn't knock you down makes you stronger, right?
That's right. And yeah, whoops, where'd that slide go? There we go. And so this is just, one slide that shows, sort of the mapping from the XML to the relational there. So anything you want to say about this, Dean?
Sure. I mean, this is just the classic problem that we have going, let's say, from XML to a typical GIS. XML, as you can see in this example, is typically object-oriented, or it's like a nested structure of one element within another. And we have to kind of unravel that because GIS is typically based on relational or flat tables. And so you can see in the coordinates there, I've got 4 values in the coordinates column. That all comes from the coordinate object on the left. So there's always this challenge of either wrapping things up to write to XML or unwrapping them when you're reading from, and also where do you slice the XML? Because we had that slide back there about the many different ways, sources and slices of XML. So that's something to keep in mind even when we get to the new XSD based XML. Even though we've got this very powerful reader, you do need to understand the structure enough to know where do you want to slice it.
Yeah, absolutely. And in some strategies when working with XML, it comes in so many flavors that you really want to have a strategy that you use when you're working with it. So Dean, what's your strategy?
Well, the basic idea is that you do have to be careful. Like I was going to say earlier that, XML, as you said, it's a lot of fun. It can also be a challenge because I think some people who think XML is fun have been very creative in some of the data structures they've come up with. And XML is actually, in some ways, I have worked with just complex text files. So the benefit of XML is that it's structured. So at least you have that benefit. You're not doing text parsing. But if you dive into it right away, you might sort of get in too deep before you realize you're not actually reading it correctly. And so before you get buried in your XML, try to think through sort of a structured approach. And the first thing is, what type of XML are you working with? Is it regular XML, GML, or some other flavor? It could be even an RSS feed or a web service. And as much as we give you really good tools to work with your data, you still need to know the logical structure. So if it's building data, you have to actually understand that building model. So there's really no shortcut there. You got to know what the structure is of your source data and what the target schema is, and then that will help give you clues about what are the transformation steps and the best tools to choose for that.
And so on reading, as Dean said, the first thing to do is identify the type, and if it happens to be like GML or city GML, then that's with FME, that's the one to go through. So
and I had a good case in point I'm going to mention, Don, on this slide. This actually just came up a couple of days ago on a support case where I was sent some XML data and they were trying to read geometries from it. And when I looked at it, it was actually a WMS, get capabilities document. So as many know, WMS is actually raster data. So it does help to actually go through some of these steps and what are the clues as to what format you're dealing with. Looking at the namespace header right off the top, when you know what to look for, you can see, this is actually a web service and it delivers raster data, so you probably won't get very good vectors out of it.
So no, good. Okay.
And then the bottom half of that slide just talks about having a look at your data. And of course, Data Inspector can read almost anything. So that's a good way to preview your data. And I wouldn't be shy about, it's a good idea to have a tool like Notepad++ with the XML tools in it, because then you can actually, there's nothing like, it's human readable. So just, don't be scared.
Absolutely. Yeah. And then writing, I guess, on the writing side, I mean, always look for the most specific writer format you have. So if you want to write CDGML or something else, then if it's there, then go for that. Yeah.
Yeah, so the more specific you are with the level of support, let's say a specific GML profile, the easier, the less work it's going to be. We'll basically, under the hood, that writer will do a lot of work for you. And
Yeah.
I mean, there is more than one way to read or write something, and so occasionally we'll come across some you know, flavor of GML. Let's say there's a problem in the application schema and we can't parse it. Well, then you could use no schema mode or XML Reader writer to deal with that, to work around it. But in general, the more specific the writer, the better. And the other thing I'm going to mention here before we leave it, right at the bottom, there, you know, take into account the destination schema. We have three basic data types for XML. There's XML buffer, which you could think of just as a normal string, XML geometry, and XML. The latter two take XML fragments, which actually have to be valid XML. So they have to have, let's say, you know, namespace declarations and whatnot. So you can actually write XML fragments within those destination attributes or fields. And then the other thing that's new in 2020 is node level writing. And maybe I'll point that out later in the demos. But the idea there is when you have, let's say, grandparent.parent.child, you can actually write to the parent using an XML fragment. So you can treat any parent level node in that tree as an XML attribute. Yeah.
Sounds good. So Dean, somehow could you do the CDGML demo as well? And then, so we'll transfer you, and then also do this really simple XML one. So.
Sure, absolutely. So can you see my blank data inspector right now?
Yep, I can see that, Dean.
So we'll just run through really quick the three ways of reading CDGML. And so the first way, and Don kind of walked through this briefly, and I'll just kind of show you what this looks like. So this is the tree control, and this, you'll see this come up again and again. This was an innovation that we made about, I don't know, 5-6 years ago. And this is a lot preferable to having to open this up in a XML editor to figure out the structure. So reading, and the other thing I'll show you here is you're not supposed to just select all, because if you select all, you'll get everything as a feature type. So I'm just slicing the XML at building, and then we'll see what we get back. And the point of this whole exercise is that there is more than one way. I guess I shouldn't say slice a cat, but there's more than one way to slice your XML or to read your data. But this is probably not the easiest way. As you can see, the geometry comes in as a bunch of properties, and there's no, when you use this mode, you're not going to get any geometry for free. You'll have to build that in a workspace. So if we get a bit more specific, I'm going to use XML Reader, and I'm going to highlight quickly here the no schema mode. So if for some reason you get data that does not have schema, you can probably read it in no schema mode. It's kind of like our QGIS equivalent, because QGIS typically doesn't use schema unless you tell it to. And so the reason why I'm using this particular mode is because if I did allow it to use schema, it would be smart enough to actually call the CDGML reader, and that wouldn't really help my demo. So.
Yeah.
So we just want to show what the XML Reader does on its own, and you can see we get roof surfaces. We've got things like IDs, properties, polygons. So it's definitely better than what we saw with just the XML Reader. But then if I go to CDGML and look at the same data, then it's a little bit richer yet. So now you can see all the textures come in. And the other thing to point out is we also get LOD, so you've got the city GML traits and properties or attributes in there, and even the geometry names themselves. So then you get the full format support. So yeah, the more specific you get, the better. And under the hood, this is actually using those application schemas. So you get you know, the full rendering. So now moving on to simple GML reading.
Yeah.
Get the slide deck up here.
Slide 32.
Thanks.
Yeah.
So if I just pop up this particular data set. So this is a UNESCO list of World Heritage Sites. It actually has to read the whole thing before it formats. And so what happens if we want to take this particular XML and read that? So I just copy that URL. And it doesn't hurt to use your browser as well. If you're looking at a web service, look at the browser. Now that it's actually downloaded that data set, you can see it's a fairly obvious structure. It's not that deep. It's not particularly complex. So we want to slice this at row. So if I go back to, this time I'm just going to go ahead and do this in Workbench, because I know that I'm going to get some geometry points and I want to let some lat longs, and I want to do something with that. So I'm going to add the XML Reader. And I just put the URL directly in there. And I can go ahead and drill through that data. It's actually resolving that URL. And that's what I'm going to get in my row. And I mean, we can go ahead and have a quick look at that. And we'll see we won't have any geometry, but we'll get back 1,000 or so sites. And this is kind of a typical workthrough of how I would go through and read some. We're calling this arbitrary XML because it does not have an application schema. It's just sort of a custom concoction of XML. So that's all great, but we want to see some geometry. So let's do a vertex creator. And we just set that up to long lat, not lat long. We always say lat long for some reason. I don't know why. And then we need to set the coordinate system so it'll show up on say a background map, LL84. And then the next step is KML property setter, because I've decided I want to write this out to KML. So this is kind of that whole step of and actually before I continue, you can, while you still see this in the background, so why did I decide this was arbitrary XML? Well, if you look at the header of this XML file, you can see there is no namespace declaration. That's the first clue. And the second clue is that there are no prefixes. There's no namespace prefix. So namespace prefix would be like GML : something. So because of that, that's kind of why we assume that this is arbitrary. So I'm going to set this to site and the content to short description. And then the last thing I'm going to do is just type bar for bulk attribute remover. So one thing to remember with the XML Reader is it puts a lot of there's some sizable format attributes, and particularly the XML fragment. So if you don't need it anymore, it's a good idea to drop that. So I'll just write this out to KML. And we'll just call this heritage sites Static. Yeah, just overwrite that one. And here we'll set this to, I gotta hook it up first. We can get the schema. We'll set this to category. There you go. So I could preview that really quick, make sure it's working. So basically we just added some geometry to this. Those are the various heritage sites. And just for some context, let's try looking at that in Google Earth. Why not use KML? It's another XML format, right, Don?
Absolutely.
So I use open containing folder. That's the one we just wrote. And as much as we love beautiful British Columbia, I do also have a place in my heart for Bulgaria, having spent 4 years there. And as we can't travel too much these days, we can travel virtually. So let's have a look in Bulgaria what some of the heritage sites are. And so we can have a look here at Rila Monastery, and that gives you all this information. That's one of the top sites in the monasteries there. And who knows, maybe they were the inventors of Beer XML, which we will hear about in a few minutes.
Later.
Yeah.
Yeah.
So there we go.
That's great, Dean. Yeah, so Dean chose KML. It is another XML format. And you can see with FME how easy it was for him to create the pop-up. So you have pins on your Google Earth there, and you click, and then up came the attribution. So that's really great, Dean.
Yeah.
So what's next?
So, and all of these demos will be available afterwards. We'll package them all up and send out a link to them. So really the key there is that with XML, unlike GML, because the whole point of GML is the geometry and or the geographic markup language. So XML, you don't get geometry for free, but as you can see with FME, we make that quite easy. And so that, like the point at the bottom right there is, we give you ways to easily extract the data you need and feed that into formats that are a little more client friendly, such as KML or perhaps PDF. Mm-hmm. Well, here we are. We're already at our first Q&A. So Trent, are there any questions that have come in? Anything that we can field or discuss before we jump into the next demo?
I've got one good one here. Can you guys give a more clear example of when to use an XML fragmenter versus the Flattener?
That's a good question. I'm glad somebody asked that. So we have examples of both in the demos. And so just kind of, Don, you can remind me if I'm running through that and I miss it. But the basic idea is a fragmenter is when, in the case we just saw, if I just jump back really quick, when we had multiple elements, then we need to use, I did this with the reader, but if I was getting this back, let's say from an HTTP caller, I would then use an XML fragmenter. The XML fragmenter is really like an XML reader in a box. So it'll give you back multiple features. The flattener, you would only use the flattener if you only have one object that you want to flatten. So if I only had a single row, then I just flatten. It's basically a subset of what Fragmenter does. So it's a simple case when you only have one thing.
You want to quickly just do that, Dean? Just throw down and have both go to an inspector. The same data set, just have the read the raw XML with just the whole file, and then have it. It'll only take you a couple seconds, and then you'll really, So as Dean's building this, as Dean mentioned, if you wanted the whole file as one big thing all flattened, you'd use a flattener. But the fragmenter enables them in this case to break it out by row. So each row by row would be then its own separate object. Yeah.
Just make sure this whole thing is doing its thing.
Yeah.
There's the data, and then we slice it up with the fragmenter.
Yeah.
So here we just go query / row. And let me just make sure if flatten is on. Oh, got it enabled.
So yes. And that's another great point is if Dean didn't turn the flattener on there, then he would have to have a flattener after the fragmenter. So, but by turning it on now, he gets really nice looking data.
Now,
there.
if I just didn't know the difference, I could have said flattener here.
Yeah.
And it's worth spending a little time on this because it is potentially confusing. Yeah. So I could just say query row. There's nothing to say we can't do this. Now, I don't know if we've retrofitted Flattener to be smart about this.
Yeah, I'm curious as well.
One. So it'll just do the first. And if I didn't really know, if I wanted to deal with the whole document and I just said query, I'm going to get one very big record.
Yeah.
A record with 1,000. Yeah, you can see. Yeah, oh, actually, you get a list. There you go.
Yeah.
So it does get the data, and there's nothing particularly wrong with this. I could have one huge record and then have a list exploder.
That's right. Then you could do a list exploder, and you would be back to having So as Dean mentioned earlier, there's many different ways to do it with FME. So if you find a list, which is the twiddly brackets with a number in the middle, then you can break it out into individual rows again or records by using the list exploder. Yeah.
And the other trick here is exposing. So I can't actually expose until I add it there.
Yeah. So there we go. So
So maybe we'll save that as a demo because now that's demo 13. We only have,
we have 11. Baker's dozen. So
you can see though the performance isn't quite as good. So
that's right.
This is another case where being a bit specific helps. And the other reason why this performance may not be wonderful is if I'm clicking on the right one, each of these has the XML fragment, which is the entire document. We now have a sort of a power, a factor, an exponential growth in the size of our file or data set because every record has the entire data set. So that's where you'd want to use that bulk attribute remover.
Okay.
So moving along.
Good.
But thanks for that Q&A, Trent. So now let's write some XML using, first of all, we'll do flat. So like some people might wish the world was flat. It might make life easier. So here's what a flat world would look like from an XML perspective. I'm gonna save this somewhere just so I've got it. None to none, that's a good workspace name. So let's have a quick look at what we're reading. And in this case, we're going to create some arbitrary XML. So we get to dictate the destination schema, and we're going to just base it on the source. So in terms of going through that methodology we outlined earlier, we've kind of made our lives fairly easy. We're just going to drag this in here, CSV, and then what I'm going to do is add, in fact, I should probably I could just go generate workspace and go from CSV to XML. This time, we're just using the generic XML. And here we go. And we'll just call this Oh, XML, sorry. So this is one of the few cases where you could use some kind of quick translate to do this. Before we run it though, let's have a quick look at the, just to make sure things are mapped. You can see here that it automatically mapped state/region to state underscore. Otherwise we would lose that data. And let's have a look at the output. A sec here. I've got to actually save the workspace first so it knows where to go. So we can look at this in an editor here. It looks a little hard to read, so one of the first things I always suggest is to use the option to pretty print, and that makes things a lot easier to debug. If you were to write XML as one big long line and then you got an error message about what row or line, it would be kind of hard to debug that.
Yep. And you'll note that we also wrote an XSD for this file as well. So
yeah, that's a good point. So there's our output, and we created an XSD to read it. So now the kind of ironic thing is that you could read this with our generic XML reader, but you would actually have to provide a feature path. And so I'm going to show now with the new XML reader, we don't need that. We can use the XSD based XML reader writer to read this using that app schema. Give it a feature path. You do have to choose a feature path, and I don't think it will automatically guess one, but there's all our data. So the population and state name there. Yeah. So we've round tripped that. So that's just flat XML reading and writing, and we've actually read it back. That's the result. Yeah. And then the next one I wanted to show you is the wonderful, powerful XML Templater. And so this one, I'm not, in the interest of time, I'm not going to build it from scratch. I do want to highlight the Templater. We do use a lot. And don't worry, those of you who are huge Templater fans, don't feel like you've been abandoned because we added app schema based writing, because there's always going to be cases where you're going to need Templater. Often if you need to just compose an HTTP post message, I probably said too many P's in there, you're going to need a Templater. So, and I think Don might have mentioned this earlier, for the Json fans out there, a lot of these transformers have Json equivalents. Templater is certainly one of them. So the main workflow here, this is just making a contact message or an object for metadata, and we'll see a fuller metadata example later. So the basic workflow here is we create a record, or we could have read one record from somewhere. It's just a flat tabular record, FME feature at this point. And the key here is we take this XML structure that we want to write, and then all we have to do to, let's say there was just a name in here, and let's say it was Joe or something. So if I had a sample of the XML object or record I want to write, I could just highlight that and double click on contact, and it would replace the literal with feeding in the value from the feature. So now where do you get this whole thing from? You would probably get this from either a sample of the XML, or you could use generate on an XSD to get a template of that XML.
Right.
So
this is why the metadata is such a great example. There's a lot of different variants, but if you can have a sample that you know you're your metadata repository is going to take. You can simply copy the XML that you know works, put it in the templater, and then as Dean says, just replace the values from the feature that you want to place, and then it will go in. Because often in a metadata record, there's a whole bunch of standard information that's not going to be touched, maybe organization, you know, and
Yeah,
things
that's
like
all
that.
sort
So,
of boilerplate, and you just want to set certain values. Yeah,
exactly. So,
and you'll also notice here I'm using the text line writer. Now, Don, why are we using text line writer and not XML?
well, it's a beautiful writer, and it can write anything that is text-based. And you've already built you've used the XML template, already built your XML package. You'll also note the XML validator in there, and that's, we're going to talk a little bit about that. But whenever you're writing XML, it's really good to use the validator. It can validate, make sure that what you're writing is valid, also that it follows an XSD if you have one, and so it's really a key thing. And yeah, and many people use FME for even the validation when they get data or they're producing data. Validation, quality control, quality assurance is a huge thing. Yeah.
Yeah, before I forget, you'll notice two things. This is gray because I think this transformer hasn't been upgraded, so you can limit the number of warnings, but we don't just say pass fail. We give you very detailed messages, and I have some examples coming up. So we'll give you a detailed messages of why it failed, what row, what column. And the other thing that's new in 2020 is that you can, if you do choose schema, you can validate against multiple schemas. You don't have to just pick one.
Yeah, so good.
So that's good. Moving along. So now we've written some XML finally. That's great. And we're highlighting the get functions. I will just quickly mention there are several types of get attribute functions. There's get XML attribute and get list attribute as well. So make sure you choose the right one. And that's just showing the template and the results. So we were just talking about validation.
Yes.
Good. Let's go ahead and have a look at this. So yeah, this is just a reminder about the possible types of validation and the fact that we have multiple XSD support. So yeah, just to highlight here, you can actually have no validation. Now that seems odd, but the idea there is that you could turn off validation because validation does cost something. And so you could have, let's say, a parameter that controls all the validators in your workspace, and you could just turn that off when you're in production. You can validate just on syntax and namespace, and then a syntax and schema, which is sort of total validation. And something we use in support is we use this to check data coming in to see if it is what it's advertised.
Yeah, so if you're having trouble reading, validate the data. There is invalid XML out there. The other thing I want to say on that is you'll notice one of the values was none. And so the reason we have that in there is you can have that, that value be a parameter on your workspace. And then when you're developing it, you can have your XML validator in there, which of course, anytime you're doing validation, it's not free. And then once you get the whole thing working, knowing that you're writing valid XML, then you can just through a parameter set that to none. And that way you don't have to change any of your workspace, and features will just zoom right through. And then if later you're making more changes, you can easily turn on and control the validation. Yeah.
And this example is not contrived. I think I had another one that was, but then I got this error while developing the next workspace you'll see. And so I got invalid character, and this was odd because it was at line 12,000. So it actually went through quite a majority of the file until it got this invalid stuff. So that basically shows, well, why is that data invalid? And if I go to that folder and look at the bad data at line 12,000, at some point here we hit nans. And so that's what's happening. The schema, it's up to the application schema to be as how prescriptive it is. And this is just using that auto-generated FME schema. It's actually controlling the data type, and it detects that Well, according to XML, nan is not known to be a number, and this is supposed to be a numeric field. And so I actually made another workspace which picked up those nans and replaced them with zeros, assume, just as a better default. And so now if we run that on the good data, we'll see that it passes. And this is run against that auto-generated, this application schema was just generated minutes ago.
Yeah.
So now that passes. We don't get a lot of happiness in here. It doesn't say wonderful data set. It just, you don't get any error messages. But if we look at how did I fix that, I used that information to put in an attribute creator, conditional attribute creator, to pick up those nans and replace them with zeros. So I won't bother running it, but that's how we solved that nan problem. And how I made, and so that's basically the same workspace that we just made, but with filtering out invalid population values. Okay, so that's validation, and we will come back to validation throughout these demos because it is something you want to do. But let's have a break, and do you want a beer, Don?
Yeah, so this is an example of a format that's out there that's being used that you won't see as a native format in FME, but it's a good example of just showing the wide variety of different crazy places where XML is used. And so with FME, it's really easy. So Dean is going to show how to work with this one too. So yeah.
So this one we're going to use the XSD XML Reader writer. Let's go look at our beer. Well, we're not planning on adding it, Don, unless maybe if there's a critical mass of people out there, or there's a business case where a brewer really wants.
Yeah, absolutely. And that's, often we do that. There's just because there's a certain, we get to the point where there's a lot of demand for it, and then it just makes it easier for users. They can just simply pick a format and away they go. Yeah.
So I'm just going to show you one issue with, or one challenge with this is if I just choose, so this is just diving into the new XSD based XML Reader writer. We do need to specify a feature path. I'll note that this feature path is not the same as the one you get when you are navigating the data set, because it's getting this feature path from the app schema, not from the data. So that's the first difference. So I do get one record, but it's not very informative. So what I need to do then is because of the complexity of the schema, you'd think beer is simple, but I guess for the brewers out there, it isn't that simple. There's a lot that goes into your mug of mead. And so I actually have to tell it which types I want to map. And so the trick here, I just kind of found this out through a bit of trial and error, is that I want to map all those as feature types, but not the units. Because if I map these into separate feature types, then they will not be members of my, let's say, recipe record. So I just deselect these guys, and then off we go. And if you have any suggestions on how to, this is a brand new reader writer, there may be some workflow improvements that we can.
Yeah, I think there's opportunities here for sure.
So here we see this particular recipe has these additions. So we have to put in some buckwheat honey and barley, wheat, and then it gives you the amounts. So if I hadn't unchecked the units, then these amounts would not have shown up.
Right. Yep.
So that's just reading beer XML. And so that's just to kind of a reminder there, you do need to pick a feature path. We'll see in a minute, you don't always have to check XSD types as features, but in this case we did because it's a fairly complex schema. We looked at the schema, if we looked at the data, I guess we can go ahead and do that because that's kind of our workflow, right? Yeah. How do we figure this out that this is actually not arbitrary XML, we can see all of these namespaces and the namespace prefixes here. And sometimes you can set up a default namespace prefix so you don't necessarily see it throughout the document. But this gives us some clue that, and the fact that there is an XSD, so this is obviously standardized XML.
Yeah.
You know, medieval ale, that's serious stuff. So you want to have a very structured data set to describe how to make that.
Yeah.
Okay. Now on maybe a little more serious topic, emergency alerts. So we want to also have a protocol, and this is another case where we have this based on an application schema. In this case, how do we write? So we're going to write out a message, and we see this come up a lot. So it's not just about how many XML formats are there out there. There's also protocols for messages, and even something like AIXM, which, you know, from a GIS perspective, we call it a format. It's really a messaging protocol. And so in terms of why is this stuff important, as we mentioned earlier when we talked about why we love XML, it's really the language of the web and messages going back and forth. And so, and it enables standardization. And so a lot of OGC standards are based on XML for that reason. So that's going to be a recurring theme here. So this is a common alerting protocol. It's used by Public Safety Canada. It's used by organizations around the world. And we're going to see how to build, or what does it look like to have a workspace that generates this type of data. Over there, demo 6. And I'll just start to, I'm not going to build all these workspaces from scratch in the interest of time. So there's kind of 3 parts to this workspace. First of all, and this is a typical pattern. You will build, normally you need to build the lowest layer first. So we're going to build the info object. And if we look in here, this is the info object. We want to add polygon and area description, and then this information here. So there's detailed information about the alert, and then there's a header, alert header. And you could have, the reason this is a list is there could be multiple information elements. And so we basically say, okay, this is a flood warning. This is about monitoring flood levels on the Fraser, which actually we just had historic flood river levels in the Fraser this weekend. And then we need a timestamp. And this is something I was mentioned in the list of transformers. We want some geometry in here. Now, this is a fairly custom schema, or it helps to actually have some sample data to figure out how to build that geometry. So this, from any sample data out there, and in fact, I have some samples here, let's say from a tsunami warning in the Aleutian Islands, we can see that it's just comma separated values for the coordinates. And so that just happens, one way to do that, it's a bit of a trick, is I use GML 212 to get a geometry, list of geometry. Now here's a case where I only have one object, so I use Flattener, and I only want the coordinates out. And then I basically set area 0, polygon 0, 2 coordinates. And that then what I can do is wrap that all up, select what attributes I'm going to wrap up, and into the parent alert object, and then here's some header information for the parent alert. So this is where I put the address, the alert type, the scope, things like that, an ID, and then I write that out. So let's just have a quick look at what the output looks like. You notice that I did not use any XML templators, so this is using the new app schema based writer. I have to specify the app schema path and the feature path. So here, this is the actual path Now you notice we're using the tree on the writer. We only have to choose one point in the application schema where we're going to create an object from, like where in the data model do we want to grab the schema. And so we're going to go right at the top, create an alert object, which actually has a bunch of components within it. So there we go. So it's a fairly long schema there, but we're not using all of it. We're just using the parts that are green. And then if we go to the output, hang on a sec here. Yeah, so there's our output. So you can see that we have a polygon defined. And now the trick is, how do we read that back in? Just to check that everything worked fine. Take that output, point it at the right application schema. So the beer one won't help us anymore. We need to go to capxsd. And in this case, we only need to check cap alert. We don't need this stuff here because it's a fairly flat schema. And there's our alert object. So we're not expecting it to render geometry because, again, you don't get geometry for free with XML. We could easily do the reverse, and I could actually use a templater to embed this geometry string in a polygon notation, and then use a geometry replacer to generate geometry without having to actually, create individual vertices. So the geometry extractor and replacer definitely give you a bit of a shortcut when you're working with XML. So there you go. I didn't really want to rush through this because we are highlighting the XSD-based XML Reader and Writer today, since it's new in 2020, and it really is quite powerful. And we wanted to give you a few examples of how that works. And you'll notice that when you're writing to a list, you need to pick an element. I can't just write area squiggly squiggly. It has to be 0. Pick an element. And in GML and XML, you often see these list types, even if there's only one, because lots of people define schemas. Unless you actually say only one, by default, most elements are defined as one or more, and it'll show up as a list. Okay. So that's writing. Here's just a quick note on validation. I said we would talk a bit about validation, and I wanted to break my workspace quickly and fix it and just show you what that looks like. So here, if I were to drop, let's say, severity here, and rerun this workspace, I have validation turned on, and it will generate an error. And this is something we see in support all the time, and it's not that intuitively obvious. We can't really give a more intuitive message, because this comes back straight from Apache Xerxes, which is the open source.
Where do you have validation turned on, Dean? I don't see a validator in there.
Ah, good point. Well, you'll see it. It's a published parameter, and it's set on the writer here. Right. Validate dataset on the left. Yeah. So it is turned on. So what this is saying is certainty is not allowed. Now, what that actually means, it doesn't mean we can't have a certainty property. It means that it expects something else first. And if you forget everything else, remember this: all these things that don't have any notation around them are required. So if it has a question mark, often if it has a star, it's not required. As question mark means optional, star means list, but these guys are all required. And so that's why I have to go back in here and select severity again, which will include that in the output.
Right.
And then that error goes away. And so that's just, I just have on the slide there 2 examples of, I thought that it's really good. You know, don't be scared of the error messages. There's a lot of information there that will help you build your output and satisfy the app schema.
Right.
Clearly, if you're doing app schema based writing, you do want to check. You might want to turn validate off at the beginning just to get things rolling, because if you have validation on, it might stop the writer completely from outputting anything. But then before you actually consider that you have valid output, turn on the validation check and make sure that you don't get these error messages.
Yeah.
Yeah. So
okay.
There we go. So what's next for XML, Don?
Well, yeah, we're definitely a lot still to do. City GML version 3, of course, you can see the list there. What's Fixem and Wixem, Dean?
Well, it's funny you should ask. I added some Wixem in here. I don't know if you caught it, but so Fixem is, so AIXM is aeronautical information exchange format for things like flight paths and airspaces. Fixem is flight information, so that's more like telemetry.
Yeah.
So if you had a black box and all the data of where the attitude of a plane and how fast it's going, and Wixem is a weather exchange format. So I've included. We may not have time to look at it all today, but it'll be part of the sample data set or package. And so Wixem and GeoSciML, those are both examples of formats you get for free just because our GML reader writer is so powerful. And we not only read it, but we can actually write it as well, just based on app schema.
Yeah. And lots of activity around SimXML as well. So if anybody out there is working with sim data, we would love to engage you to, continue our work on SimXML. Sim stands for Common Information Model, and but there's variants. So the word common is in quotes.
It's just like common for alert protocol. Yeah,
it's like if you have the word democratic in your country name, you're probably not democratic, like North Korea, for example. Yeah.
It's actually in an XML land, when you see the word simple, that's kind of a red flag.
That's right. I'm old guy, so I remember CORBA, Common Object Request Broker Architecture, and again, it wasn't common, and so yeah.
Okay, so we have time for a little bit more Q&A in our XML marathon here. Has anybody piped up with any questions?
We've had one question coming a few times in terms of nested writing. How complex can FME handle with XML nested writing?
Well, I'd like to say we can pretty much handle anything. Sometimes there's going to be an easier and a harder way to do things, and so that's a good question. We have a lot of examples on our knowledge base. One that we have some good examples for is AIXM. And so with AIXM, given the nested geometries, what you have to do is just the pattern you just saw. You have to kind of define the properties and name the geometry, put it through an aggregator for every level of nesting. And so you can imagine with 7 or 8 levels of nesting, you're going to have 7 or 8 aggregators and then 2 or 3 building transformers. That's a lot of transformers to write one object. And so in that case, that's a good case in point where you're better off creating, having the complex structure in an XML fragment and then using XML Templater to feed in maybe the geometries. And that's where GML Feature Composer comes in handy, because it lets you build a GML fragment based on an app schema. So we could, we definitely need to put, we're going to update perhaps the XML tutorial to have some examples of that. So I'd like to say we can, go crazy with the nesting. FME should be able to handle anything. If there's anything you think we can't handle, send it to us and we'll give you a hand.
Yeah, and there's live chat on our website. So certainly if you're working with someone, a complex, heavily nested XML document, just reach out there. I think if there's one takeaway, you can see that Dean is really an expert in how do you work with XML? What's the best approach within FME? And folks like Dean and Trent and a few others at SAFE really can just save you so much time by maybe providing a sample or telling you the approach that should be used. The challenge of having many ways to do something is often there's the path to success is on multiple ways, but there's an easier way and a harder way, and that's really where our live chat can really help you. Yeah.
So
So
how much?
Dean, yeah.
How much more time? I mean, we're
We
just
have officially we have 4 minutes. We have 19 minutes officially.
officially at 19 minutes. So we'll go through some of these pretty quick.
Yeah.
I think metadata is a big one.
Yeah.
And I don't know if you guys ever said we won't do metadata. I think we've always done something with metadata, but certainly there is always a debate: is metadata data or not?
Right.
And,
Well, I've never metadata I haven't liked. So, but again, as we talked about earlier, there's the XML templater, right? That is really key for these things like metadata, where much of the record is for a particular organization is going to be static, and there's just key fields you want to update. So, yeah.
Yeah. So let's have a quick look at this workspace. And this is really a bit of a hybrid, and just goes to show that there's really more than one way to solve a problem. So this is an example where you have an XSD XML reader and writer in the same workspace. Our goal here is all we want to do is update the contact information. So let's say the contact information for this data set has changed. And so we've got this huge MD metadata document. If we were going to do this only with the old XML reader writer or the text file writer, we would have to have XML templaters for the entire document, which, as you can see, is quite complex. You can scroll through this whole thing. And so instead of that, I'm using the XML writer, the XSD-based XML writer, and I'm only gonna, if you go scroll down here, you can see the bit that's green. I'm only gonna write the contact information. There it is. So this block here, which has contact, and it's actually an array because, or a list, it could be more than one element. So what I do is basically create the new information. So I add some new contact fields, and then in the templater, I feed that in. So this looks like the workspace we had earlier, except now this XML fragment that I create, the contact element with all the values that I'm updating, will get fed in. And instead of writing it to the root and writing out as a text file writer, I'm going to write it out as contact 0. So let's have a look at the output of that. So here's the input, and you can see it used to be Johan van Plasmoiden, who's some mysterious person over at a national mapping agency, I guess in France. I've updated that, just wrote this out now, and you can see the new data there. So we have this big metadata document. We've only updated the contact object here, and with that information. Now the other thing I want to highlight here, and it was on one of the earlier slides, this is an example of node level writing, and that is that this is new in late 2019 and in 2020. When you have something like this, say file identifier .code.codelist, you have a nested object like that, you can always choose to write an XML fragment at any level in that tree. So if you don't want to go to the work of, let's say, building aggregates or nesting lists, you can always make an XML fragment for any level of that tree, so long as it's valid against the schema for that
Right.
So we'll have examples of that. So I think, so that's metadata. Just a note there about feature paths on the reader and writer. Those are pretty critical, as well as the app schema. That's basically it. There's the source and the destination. And so the last, I wanted to run this one live because I think, metadata is a big theme. Another one is just there's so much data out there, Don, right? Like on the web, it's just a crazy amount of data. And now there's OSM data for right around the world. Like if
Yeah, OSM is, and I think the dream with IMDF is that it'll become like the OSM for indoor spaces, because it too, even though it's indoor, it's geographic coordinates, and so it just fits really nicely giving context because you have lat long coordinates. So it would be a real nice dream if the entire world also had IMDF for the all the public indoor buildings. Yeah.
Yeah, that'd be cool.
Yeah.
So this is just an example of taking the OSM data for Central Vancouver, and I've taken the buildings as well as a few other feature types. And then I'm just extruding that based on the number of floors. You can see there's a little arithmetic expression here where I'm saying, oh, yes, approximately average of 4 meters per floor, and writing that out. So I won't spend too much time generating a third-party format. I'm just going to run that out to Data Inspector.
Yeah.
And so it's just an example of, so much data out there. FME lets you access it and then manipulate it to whatever you need. In this case, 3D.
And again, a wrapped format here just did so much for us. Yeah.
And you have the full schema as well. So there's a lot of information that you get from OSM. The address, the building types, things like that.
Yeah. Yeah.
And then the other objects. So that's some 3D data. No webinar is complete without at least some cool 3D stuff, right? And this one is probably worth a quick run through. I think we saw an example earlier where I used an HB caller. Here's an example where there's actually a sequence of 3. So what happens is I actually used the FME infrastructure, the tools that you have with FME, to make a CSW reader. I've done this before with WCS. It was on the hub for a while. Then we added support for WCS as a format. So I think we may have taken that off the hub. But there's a lot in terms of web APIs. There's a lot of data sets out there, and sometimes it's not just a simple get call. So in this case, it's an OGC catalog service. It's somewhat soapy in the sense that you have to compose post commands and send them over and then parse the results. So the first request asks for the entries in the catalog. The next request gets details on an entry of interest. The last request actually fetches the data. So I'll just run that one real quick. We're almost in the home stretch here.
Mm-hmm.
You see, all these ones are really quick. So the last couple of demos, I'm just opening up data sets. And this is actually using a catalog server that was part of the OGC Maritime Limits and Boundaries project that just wrapped up. So you can see here's the first caller. It sends out a request to get the entries from the catalog service. And then the second caller gets the detail, and then the third one actually gets the data. So if I turn this off, here's a couple of the entries, and I can view that as a table. And so there's all the information on that particular data set. Then I can look at the details and, oh, what is the actual URI to fetch that data? And then finally, I go ahead and grab the data. And in this case, it's actually getting the S121 GML and rendering it. And you can see that's a complex schema. Zoom in here a little bit. So we can look at it one location, and you can see that there are nested properties there. So
Right.
there's multiple spellings based on language, and references to other links to other parts of the data set. So this basically retrieved all the data for the selected item of interest, and you can see I choose from WFS, WMS, etc. So essentially, this is a quick and dirty CSW client that we made, and that involved, in the first case, a fragmenter because there's multiple entries. In the second case, we just flatten so we can get things like the URL. And in the last case, we actually use a feature reader to get all the WFS features out and actually retrieve the data. Okay, maybe we'll save. I guess, are we at the last Q&A?
Yeah, we are. So yeah, so we should show the resources there because some folks will probably have to dial out. So yeah, but is there any questions, Trent, that you want to highlight?
I've got one good one here that I think is kind of interesting. Is there an advantage to using the XML Templater or updater versus the Xquery updater?
I think the XML updater is probably a bit easier to use. The Xquery updater, you have to write valid Xquery expressions, and sometimes those can be a little bit tricky with the syntax. There's no real one right answer, but
Right.
I would say the XML updater is just a bit more full featured. Like for example, the updater, there's an example on knowledge base which shows how to use XML updater to do a simple delete operation. Yeah. And that would be a bit tough to do with the Xquery commands.
Right. Okay.
So I guess Don, you got a webinar.
Yeah. So tomorrow we're going to we have the unveiling of FME 2020.1. So we have another webinar then that. So sign up. Go to our website. Sign up for that if you want to learn about all the stuff that's in FME 2020.1. And I have to say that this .1 release, it has more new stuff in it than typical .1 releases. Part of the reason for that is we were expecting to highlight all this new functionality at our user conference, which was going to be in June, so just less than a month ago. And of course, that didn't happen due to the pandemic. And so, but the team kept working, of course, and we've been able to get the functionality in. So lots of new things, both on the FME workbench, the authoring experience, and of course on the server and in mobile apps. So lots to see tomorrow.
Lots of cool new stuff.
Yeah.
So if don't forget in the chat, I mean, before we go or while we're wrapping up, if you have any ideas about what you would like to see in terms of our XML or our JSON processing, whether it's a new format support, something like City GML3, or it's maybe nifty new tools or improvements to our list processing, please do pipe up. I will just point out here, I'm just going to flip through these slides and then we'll get to the end. This is available on the hub. This is a green building XML reader. And so those are just some examples. Those data sets will all be in the package that you get. And what this does, it actually does the low level. It explodes everything down to the vertices and then reassembles them. Point connector, line connector, and aggregators, and actually goes all the way down from the vertices back to the spaces that compose that particular BIM model. So it'll take output from Revit and a number of other formats. And this is just another example of, this is XSLT. We didn't really have time to get into it, but if you
use the back end just to the Hub one just quickly, I just want to make sure that people know about FME Hub. So if you type FME Hub on Google, then you're going to find a lot of other formats, transformers, building blocks that are created by us as well as our community. So a great way to, find other stuff that can save you a ton of time with FME. Yeah.
And so I'm just putting a nod here that on the GML and the XML writer, you have an option to do post-processing with XSLT. And so for this particular pilot, one of the outputs, they wanted an automated way to generate legal text. Does that sound a little risky? But anyway, yeah, so this tool will actually, the XSLT will actually generate human readable or regulatory text that could be automatically submitted to the UN for maritime boundaries.
Yeah.
And so this transformation went all the way from DFO's geodatabase to HTML via S121 GML. So there'll be a link to that on the website. And finally, these are the ones that I mentioned earlier you get for free. So just using the app schema alone, you can read GeoSciML. Here's Wixom that I mentioned, Don. So there's an example of reading that airspace information. And that's these formats are all sponsored by or developed by Eurocontrol and FAA. And then here's that S121 data again from that OGC pilot.
Yeah.
The data itself is from CHS.
Mm-hmm.
And then the last thing I'll mention is the, moving between XML and JSON. So sometimes, each of them have their strengths, but sometimes you might need more lightweight data for a mobile client, and he helps with that as well.
Yeah.
And we've already talked about some of these enhancements.
Yeah.
One thing I will underline is that there is no app schema mode in JSON, and so you do need to use templaters for complex nested objects. But the neat thing about JSON is you can actually just drag and drop it into GitHub and see it, render it.
Yeah.
So lots of things we didn't have time to get into. As I said, XF maps, XSLT. You could read anything with XF maps, right, Don?
Yeah. Yeah, it's a building block underneath that many of the formats with FME are using XF map technologies under the hood. So and that's really the story of our FME XML adventure, is building. Juan has built lots of building blocks that then we can layer things on and on and on, and that's how we ended up with XSD support now, reading and writing. And please let us know as you're using FME what we can do better, what we're not doing too well. We don't for any stretch even imply that this XML adventure is over. It's a fun adventure. It's a challenging adventure taking something like XML and working to make it easy and fun to work with. But we're not done yet.
Yeah, I think there's a lot of potential for great new opportunities. Maybe one of you at our next UC can come and show us how you used FME to support your machine learning, because you could use FME to mine metadata tags and use that for training. So yeah, the sky's the limit, really. It's up to your imagination. And there's other formats we didn't have a chance to get into. All the things related to BIM and AEC, like 12D XML and IFC XML. So here's just some of the key takeaways we wanted to make sure we could leave you with before we wrap up. Certainly that new XSD-based XML Reader writer, I think that's just the tip of the iceberg. I just had a few fairly simple examples, but there's a lot more. You're probably going to see a whole new series of formats that are based on that. Don't forget about the GML Reader writer, either in no schema mode or XSD mode. It's extremely flexible. It also does the work under the hood for the WFS reader and keeps evolving. So if you have any valid GML app schema, chances are you can probably work with it with our generic GML. And really, FME is your no-code XML solution. You may have to put a fragment, copy and paste the fragment of XML element definition, but that's about it. Like you have so much power without having to worry about updating, your latest, libraries.
Yeah.
And we're constantly evolving, so we'll address things like the upcoming OGC API. And I think really the bottom line, from my perspective, is that FME's XML and JSON support is really critical, both for web integration and open standard support, whether it's W3C, OGC, Inspire, ISO, and others. So I think that really helps people build enterprise applications, share them over the web, and exchange and harmonize data.
Yeah,
so
exactly.
Anything else you wanted to highlight, Don?
No, I just wanted to stress the application integration. And really the key, the fundamental building block of that is how easy we make it to work with JSON and XML, because those web services really are just slinging, small messages around, and FME makes it easy to tie all that together again without having to write code. So yeah.
Yeah, and that really feeds into like you said, like suggested the new functionality that we have in FME for things like FME server automations. So being able to pipe those messages around seamlessly. So there's some more resources there, just repeating that resources slide. The closest thing we have to a GML tutorial right now is the Inspire one, because it is based on its app schema reading and writing. And we will have updates to a lot of these tutorials as FME is constantly evolving. So we'll add content for XSD-based reading and writing to the XML tutorial. Yeah. But please don't be shy. If you have strange, wild data sets that need to be tamed, send them our way, and we'll give you a hand with that.
Yeah, exactly. And your questions are so valuable. Often a question will answer it, but then we'll say, that really should be a knowledge base article, because there's so many different types of data out there, so many interesting data types. And sometimes it's a matter of a nice knowledge base article that shows you how to do things. Yeah.
And while we're checking to see if there's any questions, I'm just going to show you how powerful the Gmail. I'm not even going to specify the app schema. The only thing I do have to do is set the access order so it ends up in the right place. And FME will just go away and read that. That's GeoSciML. That's one of the most complex GML schemas out there. And it's aligned with Inspire geology. And it's also now an OGC standard, and we just read that out of the box. So, were there any questions that came up? Trent, anything else?
I don't think any other ones. There's a couple that will email us directly, just with some problematic data sets or workflows, but for the most part, I think most of the questions have been answered, I believe.
Perfect. Yeah, great. Well, certainly want to thank everybody for their time. We know everybody's super busy, and we tried to make this valuable by just showing you a wide variety of different things you can do with XML. I also want to thank the team at SAFE, Dean and Trent. You guys it's just a joy working with you, and makes me just happy every day to come in and talk to Dean about XML. He really is the product owner of XML too, so he is a great guy to talk to on so many levels, and he talks with me on a daily basis about our XML technology and works directly with Juan and the XML and JSON team. So yeah.
I mean, I did value my time in Europe, getting knee deep in Inspire, but it was great to come back and work directly with the XML team and help FME evolve. So that's really been a joy. And I do want to thank Don for the idea of doing the webinar. We look back and it's been about 6-7 years since we did the last XML webinar, which is hard to believe. So thanks for prompting us to do that. And I especially want to thank everybody, the whole audience out there, for your time, and your attention. And ultimately, we just want to save your time in the long run working with complex data sets like XML and JSON, and so that you can get to doing the work that you really want to do and not sit there and wrestle around, in circles with trying to decipher and compose data. Make that process as easy as possible. So yeah, thanks everybody.
Well, thank you.